Okay, in the previous video, we discussed about how we can design a beam for moment. But in a member, there is not only moment, there is also shear force and sometimes maybe axial force or torsion too. So in this video, we are going to deal how we can design the RC beam for shear force. Okay. So this is the different question than previous one because we can design the same question after calculating the total shear force, but we are going to deal with the new question where we have already the size of the beam and reinforcement provided. So on the basis of this information, we are going to discuss about the design of the beam with shear force. So okay. Okay, so look at these given data. So we have the effective depth is 450 mm and width of the beam is 300 mm, whereas reinforcement provided at a tension zone, or you can assume the tension is in bottom. So this is bottom reinforcement, that is 320 mm bar. Likewise, the concrete grade is M20 and steel grade is Fe250, and that means FCK is 20 Newton per mm square, and characteristic strength of the concrete Fy, that is 250 Newton per mm square. Also, we have the shear force, that is 200 kilonewton. As this is the service shear force, we have to convert this service force into factored shear force by multiplying 1.5 times, so that will result 300 kilonewton. So total AST provided is 942 mm square, and we need the percentage of steel provided to calculate the shear capacity of the concrete. So we have to change this reinforcement provided into percentage of reinforcement provided by dividing the cross-section area of the concrete. So that will result 0.697 percentage. Okay, so we just have all these values. You just put these values into this equation, and you can get the value of percentage of steel provided. Okay, so as we have the value of percentage of steel, we can calculate the shear force resisted by concrete by using the shear force capacity of the concrete for different percentage of the steel. You can use IS 456 2000 to see these values. There is a table, and you can interpolate between 0.5 and 0.75 to get the permissible stress, shear stress for the concrete. So you can just interpolate these values. You will get the value of permissible shear stress for concrete, that is 0.543 per mm square. Okay, so as you have the value of width and depth of the beam, you can calculate the permissible stress. Using this permissible stress, you can calculate the shear force resisted by the concrete, that is 73.305 kilonewton. So the applied shear force is 300 kilonewton, and the shear force resisted by the concrete is only 73 kilonewton. You have to provide stirrups to resist extra shear force. Okay, so overall in RC beam, the total shear force is resisted by in combination of RC concrete and stirrups. Okay, so on the basis of percentage provided of longitudinal reinforcement, the shear capacity of the concrete is different, and you can use the tabulated data using in standard code to find out the exact value of the shear capacity of the concrete. So the excess shear force is now need to be resisted by the stirrup. So So before using this equation, you should calculate the value of extra shear force that should be resisted by the stirrups. So the extra shear force is 226 kilonewton, and we have another equation. Using this equation, we can calculate the spacing of the stirrups. Okay, so look at here carefully. So the equation is that is VUS equal to 0.87 Fy ASP multiplied by DYSV. Okay, so you know the value of Fy. What is ASV? You know the value of dV, where SP is the spacing of vertical stirrups. Okay, spacing of stirrups. Okay, so what is ASP? ASP is the area of this vertical stirrups. What does that mean? For example, this is the cross section of RCB, and there are these are reinforcement provided here. If you provide the stirrups in this way, okay, then ASP is 2 times area of cross-section area of stirrups. Okay, so why we multiplied the area of the stirrups, cross-section area of the stirrups by 2? Because it is 2 legged. This is 1 and this is 2. So you should multiply the area of stirrups by 2. If you provide another leg here like this, okay, like this, then you should multiply the area of the cross-section area of the stirrups by 3, because you provide here 3 leg stirrups. Okay, so as if the shear force is large, you may have to provide 3, 4, up to 5, 6 leg stirrups. Okay, and just in this case, we just assume that the leg of the stirrups is 2. If it is not sufficient, then we will add another leg to resist that shear force. So we assume the diameter of stirrups is DS is 10 mm. Normally we use the diameter of stirrups is either 8 mm or 10 mm. So we assume here the diameter of stirrups is 10 mm and 2 legged. So ASP is 2 multiplied by 5 by 4 multiplied by 10 square. So that will result 157 mm square. Put all the values in this equation to get the value of SP. That is the spacing of the stirrup. So the spacing is 67 mm. Okay. So there is also some criteria about the maximum spacing. You should recheck this spacing to the maximum permissible spacing. So the maximum permissible spacing given in the code is minimum of 0.75 D or 300 mm. It should not be greater than this limitation. Okay, so that will result 387 and 300 mm. So we should not place the stirrups greater than 300 mm spacing. In our case, we just get the spacing of required spacing is 67 mm. We can continue with that one. So we can assume that, or we can adopt that the spacing of the stirrups is 50 mm. Okay, as adopted. So the final figure will look like this one. This is the size of the beam, that is, this is 250, no, this is 300 mm, and this is 450 mm, and bottom reinforcement is already given there, so this is 320. Okay. This is 3 bar 320, and assume that the top reinforcement is only 2, so the stirrups goes like this one, this. So we should provide the spacing of this bar as 50 mm. So you should write in this way: 2 leg 10 5 bar at the rate 50 mm center to center. So in this way you can design the RC beam to resist shear force. So the previous question, so just combining the previous question and this question, we can calculate the, or we can design the whole beam after calculating bending moment and shear force. So only the whole design of the beam will be completed.